Hi everybody and welcome to the talk Getting Practical with AST Transformation. The title says in an hour. So the best setup for this talk is actually 90 minutes, hour and a half. I did it in 60 minutes, it was a little bit stressful. I did it in 45 minutes, it was really fast. And we have 30 minutes, so buckle up. It will be really fast. Jeff here did the talk previously about metaprogramming in Groovy. He mentioned compile time metaprogramming. Those are the AST transformations. Let's talk about that for a second, but first let me introduce myself. My name is Baruch. I'm a developer advocate with JFrog. It's a startup in California, Israel, and France. We have two products. Both of them are heavily invested in Groovy. Bintray, most of it written in Groovy. So that's why I'm talking with you about Groovy today. We have quite experience with it. We love it, and that's why I'm sharing it with you today. So before we start, let's understand why we need these transformations and how it actually started. And for that, I will write a very simple Groovy. Very simple Groovy class. It will be a class person. I have this cheat sheet and agenda all in one. So let's write a Groovy class person. It will have string first name and string last name. I will compile it, and then we will see what we actually got in the bytecode. It's done. Let's open it. Let's open the class. So here, I will open the AST talk, and it will be in. That's not the correct one. That one. Build. Classes main org Devoxx person, and I will open it in IntelliJ here. Did it happen? Yes, okay. So here we have the decompiled code. And of course, except of the two fields, first name and last name, we will see here that getters and setters were generated for us. And that's very nice feature of Groovy, and it's actually war on boilerplate, especially Java boilerplate. So it will generate a lot of code that you would write yourself otherwise. And the question is, we have a lot of boilerplate, and it's sometimes common. Like we always need to write getter and setters. We always need to implement equals and hash code and constructors from parent and toString and this kind of stuff. But sometimes it's very, very limited to something that we try to do. Okay, not all boilerplate is the same. And Groovy have this flexible ability to add more and more boilerplate fighters in the way of AST transformations. And there are a lot which are built into the language itself. For example, toString, which you are probably familiar with. So if I'm going to compile it now, and let's see if it's got refreshed. No, I need to do this thing again. Okay. And yeah, and now we can see that toString method was generated for us. All this is not new. Of course, you probably know about it, and if not, you really should. And this is the compile time metaprogramming that comes with the language. Those are the AST transformations. And the purpose of this talk is to show you how you can write your own AST transformations to fight boilerplate, to provide additional means of extending the language, extending your usage of the language, and of course reducing the amount of code, the repeatable code that you need to write. So this toString, what it is and how it is written, that's exactly what we are going to talk about. So AST stands for Abstract Syntax Tree. Abstract Syntax Tree is the representation of the source code or the bytecode that has, which is a tree. So for you to understand how it works, I will start with a very nice picture, the explanation about Oxford comma. It's too small. All right. So here is the sentence. We invited the strippers, comma, JFK, comma, and Stalin. And you can understand that we have three entities on the same level. This is the party that we have, and we have all three of them here. And now we remove one comma out of it, this one, and our sentence will be without this comma. We invited the strippers, JFK, and Stalin. What happened? The tree changed. Now we have completely different structure that looks like that. Now we have strippers, which are JFK and Stalin. Okay, so except of waking you up a bit with a nice picture, the idea is to actually show you how expression, a simple expression, a sentence, can be transferred to a tree. And it's the same with the source code. And I will show an example from source code, from Groovy source code. One of the nice ways to observe this tree is using a Groovy console. That's a tool that is built in into the Groovy SDK, and you can just run it, and you can run here scripts, Groovy scripts, and then try to execute them or try to observe the AST tree. So I'm going to write here a very, very simple expression. 1 plus 2 equals 3. Let's run it. Run it, and the result is true, not surprisingly. And now I want to see the AST. So we have here inspect AST in the menu, and this is the AST tree that we can observe. So our script generated the main method, and here we have the expression statement, and here we go with the run block statement. Okay, so here we go. This is our expression. Groovy added return. We don't care about that. And here we have binary expression 1 plus 2 equals 3. It's binary expression, which means that it has two parts, left and right. And on the right side we have constant, which is 3. On the right side of this tree we have another binary expression, which is 1 plus 2, and it has two leaves as well, constant 1 and constant 2. So we have a tree here, right? And this is exactly how it looks with the constraints of swing, which makes it extremely ugly. But anyhow, this is a tree. You can still see that this is a tree. So this is the abstract syntax tree. And what AST transformations do, they manipulate this tree. And this is exactly what we are going to learn to do just now. So let's go back to my cheat sheet and see. Okay, so we spoke about Oxford comma and the AST browser. Okay, now let's actually write an annotation, a transformation. And what I want to write is a transformation that will add a field to any class inside our code. And when I mentioned any, here is the time to explain about two different kinds of AST transformations. We have global transformations and local transformations. Global are global. So when I'm talking about changing all the code, I will use global transformations. Local transformations are executed on some part of code, which is usually marked with the classic metadata for marking code, and this is, of course, annotations. So the toString annotation that I showed you is a local transformation because it only adds toString on a class which is annotated with toString annotation. So we will start with a global one. And in spirit of test-driven development, we will start with a test. So here we will write a Groovy class, which will be our AST transformation test. There is a small challenge in testing AST transformations because, for example, in IntelliJ, they are part of your code. So for writing code that for testing code that manipulates some code, you cannot do it in the same code base. For example, with build tools, with Gradle, of course, but even with Maven, you have two different phases. You compile the main code, and then you compile the tests. So by the time you compile the test that tests your AST transformations, the transformations code itself has already been compiled. That is not the case in IDEs. In IntelliJ IDEA, I have the sources and the tests which are compiled together. So I will do something else instead. I will evaluate a test code in runtime. That means after the code been compiled and AST transformations are ready. So, okay, so I have this test class, and I'm going to write test void every class should have author field. That's my test, and what it will do is it's going to run a script and assert whether it was successful or failure. And the script will be Groovy script. It will be very easy. We have a class, and then we expect author to be there. I would say that why I cannot run it, because I have no, probably can run it. Run. Where is my run test? Here. All right, so I run the test, and it fails. It fails because missing property exception. There is no property author in this class. So now we will actually make it work. And for that, we will write a class. AST transformation is a class, and it will be author header AST transformation. We will write the AST transformations in Java for a number of reasons. First of all, if you don't write Groovy every day, it will be easier for you to see Java code now. And also, of course, for the sake of the performance. Think about it, especially global AST transformations, they run for every class that you have. They should be really, really fast. We can make Groovy run fast as Java. We're going to talk about it, but for now we're going to write AST transformations in Java. So we will create a Java class author header AST transformation. Okay, so I have all the imports. Author header AST transformation extends abstract AST transformation, and also have a notation that actually tells the world that it is a Groovy AST transformation. It contains the reference in which phase it should run, and you can see here there are 7 phases during the compilation of Groovy code. I definitely not going to get into which they are. The important part is that there are 3 phases which are particularly suitable for running AST transformations. The conversion, semantic analysis, and canonicalization. They are not too early for the construct that you need to operate are already created, but they are not too late in order to be in time to change your transformations. So those 3 are actually good choice. And here we will run it in the conversion state. Visit method suggests that we are talking about visitor design pattern, and compiler, the Groovy compiler, it implements visitor. It just goes traverse through this AST tree, and that's fine. And we have 2 elements that are passed into our transformation, nodes and source. Nodes are talking about particular nodes which were annotated with annotations for local transformations, and source is the whole source code. And that's exactly what we need for the global transformation. So we will use the source. And we're going to iterate through all the classes inside our source, and for every class in it, we are going to add field. So we're going to add field which is named author, and each public static final of type string, and it's actually a constant with a string in it. That's actually all. Now let's try to run the test again. And it still fails with the same exception. Why? Because we have this class, which is very, very nice, but we didn't register it in any way with the compiler itself. So Groovy actually have no idea that this class exists. So registering Groovy AST transformation is done through resource services locators, and Groovy expects AST transformation classes to be present inside meta-inf services. We're going to put it there, and inside this class we need to put the fully qualified name of our transformation. So that's what we are going to do, and that's actually all. Now let's try to run it, and voila, we have a new field inside a class which are never there, which is quite impressive, I would say. So now we have, like, we need to go to the Q&A right now or something, but we have 90% of the talk ahead of us. Okay, now we will run another one, which will be a local transformation. And the local transformation are different because we need to create an annotation for it. So we will start with annotation, again, plain old Java annotation. So here we have main Java, and we are going to create a messenger annotation. Okay, so what I will try to do now is having annotation on a class. For every class that is annotated with the messenger annotation, it will be a method added automatically, method message. And this annotation will have a parameter which we will just write in a second. So first, let's start with the retention. As you might imagine, we only need this annotation in the source, because by the time the compiler done with it, it's already done what it should done, and we don't need it anymore. So source is good, and the target will be a type, because as I mentioned, we will mark classes with this messenger. And here I want to have a property which will be a boolean shout. And shout will, of course, issue the message in caps. And without the shout, we will have the message just printed normally. Okay, so that's our annotation. Now we can run test. We can write test that uses this annotation. So we have another test, and it will be every class with messenger should have message method. Okay. And test message. Here we go. Okay, so here we have a part when I steal the standard system out to be able to assert on it. That's not interesting. And here we have a class quiet foo, shout false, and then I can use the method message to issue a hello world and expect it to print hello world lowercase. And then I have loud foo, which also have messenger and have shout set to true. And here I expect the same hello world message to be printed in caps. So let's run the test and verify that it actually fails. It is. No signature of method quiet foo message is applicable, and it suggests me to run isCase for some reason. And now we are going to add the annotation that will do it. So here we have message adder AST transformation. That's the one. Again, we will stick with Java. It will be the Java class. Okay, so that's the same class. Now I use another compile phase. It will be semantic analysis for this matter. And here I'm going to use the nodes this time, because now I only care about classes which were annotated with this annotation. So I take the node of the tree which presents the annotation itself, because I will need this property out of it, and then I take the member of this annotation, which is the shout, the property, and I will then evaluate whether it's true or false. And of course, I need the class that this annotation was put on, because I need to add the member there. Okay, and now I need the call to uppercase. So that will be the message, will be the variable that I'm going to extract from the arguments of the method. And to uppercase call, it's actually a method call expression. It calls a method. The method will be on the message. The message is string. It has to uppercase method, and it doesn't take any arguments. So this is actually message dot to uppercase. And whether I use it or not, we will know by evaluating the shout. So now this is the code that's going to be injected in the method. So here I have expression statement. That's a one-liner method, and it will be a method call expression. We will call println on this object, and that's a groovy way to do system out println, right? We have println added to any object, so this dot println, and then what we are going to print, we are going to use the ternary expression with the question mark and the semicolon, and we will ask Boolean expression whether shout is true or false. The shout is the variable from the annotation, and if it is true, then we need to call to uppercase call. Otherwise, and print the results, of course. Otherwise, we will just print message. So this is our code, and now we need to add this code to a method. So here we go, message add method. Annotated class, that's the class that we used. Add method, now we add method, named message. It's public void. It has the parameter of string that is called message. That will be the same parameter that later I will print. And it doesn't throw any exceptions. And the content of this method is the code that we just generated here. So that will be the transformation. Now let's run the test, and it still fails. It still fails for the same reason. We didn't register it. So now let's go and register it. Local transformations are registered in the level of the annotation that they used. So all we need to do is going back to our messenger annotation and add another meta annotation here, which is Groovy AST transformation class. We refer here to the class that we just wrote, message adder AST transformation dot class, and that should be enough. Now I can run it again, and hopefully it will be successful. Right. So now we actually added this method to the class that we used here. Okay? And now this is hell of AST. This is not trivial transformation. It's still, I would say, 10% of the production code of your production transformation, but it starts to become complicated and interesting. And here is another local transformation that I want to show you, and it will be adding main method. So what I want to do is have another annotation, org Devoxx AST main. It will be Java class, and it will be annotation, and this time it will be still for sources, but only on methods. Target on method. What I want to do now is mark a method in a class with main and generate and make this transformation generate a main method for it, public static void main. So now I have this main, and I can run my and I can write my test. So it will be test void method class with method with main should have public static void main, and of course it should run it. Okay, so here I have this class foo. It has a method greet, it has main, and then I run foo.main with args and expect it to work. And of course it won't work. Whoop. Now we can run the method adder AST transformation. Yeah, the main were in the wrong package. Oh, wow. I put it in 2 packages. Okay, so it should go here. Okay, and now let's write another one. Yeah, now it fails, no method, no signature of method, which is a good failure. That's exactly what we want. Okay. Still, same code exactly. We will use canonicalization just for me to be able to pronounce it well. And here we have the annotated method and the declared class. We don't need the annotation itself because it's only marker. There is nothing interested in it. And here we have empty array. We will need it for the for our string array of main, and the constructor call because we will need to create an object now, right? The main will be static, and we need to generate an object in order to write the method. And now we can actually see the code that we are going to add. Again, one-liner method. Our main will be one-liner. We will create a new object and then run the annotated method on it with no arguments. Okay? So what we are actually going to do is adding call to greet, like new foo dot greet, and then it will of course run. That's what we are trying to do. And now let's add the method itself. Here we go. Add method, the name main, it's public, it's static, it's void, it accepts array of strings, and it doesn't throw any exceptions, and that's the code that we are going to add to it. And now we already know that we need to register it, so we add here Groovy AST transformation class, classes main adder AST transformation dot class. Right? Now let's see if that works. Oh, main adder. Someone in the wrong place again. Main adder AST transformation class. That's the good one. Okay, that's cool. Now, that's even simpler than the one before, so why bother to show you? My question is, how do you feel about it? Is it good enough, the main adder? Is it something that we can actually work with? Do you see any problems in it? There are actually tons of problems in it. Yes, just shout. We don't have time. Exactly, we can annotate 2 methods in the same class. We can actually already have a main method. We can annotate a method which have parameters, and I just run a method without parameters. This annotation is shitty, this transformation, right? Because there are so many things can go wrong here, and we didn't prevent any of those. So I don't have any time now. So instead of writing a test that will fail if we try to generate second main method, I will just show you how to prevent it. And all we need to do actually here is start running protective code. So here we go, a little check. If the class already has main method with an array of strings as parameter, then add error. Right? And that's one of the most extraordinary things about writing AST transformations. You can compile errors with your messages. That's like super cool, right? So no, I'll write a test for it because it's cool. It will be test 2 mains. And here we go. I just have main method and I add another one. Boom! That's not the one. No, that's null pointer exception. That's not one. Okay, I don't have time. Time's up. Okay, so as you saw, it's doable, but it's hard because you need to really understand all those mechanics of how the tree works. And before I leave, I just want to show you very neat tool created by this guy, Sergey Yegorov. You can find him on Twitter, on GitHub, and find this tool on his GitHub account that can actually not only show you the tree browser that I showed you earlier in the Groovy console, but also generate the AST code that you can just take and use. So all those guys are actually something that you can throw inside your transformation, and then you will not have to figure out all this stuff, which you will probably won't be able to figure out without copy-pasting from other examples or learning about it. So that's a very nice tool to do that as well. Well, that will be all for half an hour. Thank you very much. I hope that sparked your interest, and just, try to do it. It's fun. Thank you.